Today we are going to talk about how to use that law of sines and law of cosines to do modeling problems. So remember from about a week ago that modeling means word problems. So we're going to be taking this law of sines and law of cosines that we've been doing, and we are going to be putting them into a word problem setting. So let's see. I think I have a word problem right here. So I'll go ahead and look at, now we can't see it. Okay. Artemis seeks knowledge of the width of Orion's belt, which is a pattern of stars in the Orion constellation. She's previously discovered the distances from her house to, and then I don't know how to pronounce the name of that star, Alnitak, I don't know, is 736 light years, and Mintaka is 915 light years, and those are the endpoints of Orion's belt. She also knows the angle between these stars is 3 degrees. What is the width of Orion's belt? Okay, so we're going to start by drawing a picture of this. So this is going to be home, right? Because she's measuring them from her home here. Artemis, or I guess that could be she, it says. I just started reading Artemis Fowl, and that's a he in there, but she here. And I'm going to say that this is star A, the Alnitak, and so that distance is 736. And then from home, also measured to the star that begins with the letter M, 915. And she knows that the angle between them is 3 degrees. And what she wants to know is the width of the belt, or the distance between those two stars there. Okay, so now I've got my picture drawn out, and I'm ready to try to solve this problem. Okay, so first thing I have to do is decide, am I going to use the law of sines or am I going to use the law of cosines? Because in the two individual lessons, you kind of know if it's the law of sines lesson, we're going to use law of sines. If it's the law of cosines lesson, we're going to use law of cosines. But what about when it's just a problem? How can we tell which one to use? So the key to the law of sines is that we have to have pairings of a side and an angle across from each other. So when we look at what we know here, x and 3 degrees, those are opposite of each other. So that's good. That could have a law of sines thing going on for it. But with our other information, 915, we don't know what's across from that. 736, we don't know angle M across from that. And we can't find them because we only have one angle. We can't subtract from 180 to find any missing angles. So we do not know any pairings of a side and an angle. The two sides we don't know angle A or angle M across from them. The angle that we know, we don't know what's across from it because that's actually our goal, is to find the thing across from that angle. So because we do not have these pairings, this is going to become a law of cosines problem. So I'm going to go ahead and just think about labeling my triangle. I'll call that A because it's already A. And then I'll call this B, and we'll call this C here. It doesn't really matter how we label them, as we talked about with our law of cosines. We can reshuffle those labels, but then when we think about this for our law of cosines, we're going to want to find what I have now labeled as little c, the x side. So I'm going to be using this c squared equals a squared plus b squared minus 2ab cosine of angle c. Okay, so that form of our law of cosines here. So then we want to plug in what we know. We do not know c because that's x. That's what we're trying to find. Little a is 915. Little b, 736. A, 915 again. B, 736 again. And c, big C, is 3 degrees. right? So everything on that side of the equal sign is a button I can press on the calculator. So I'm going to do that. Grab my calculator. 915 squared plus 736 squared minus 2 times 915 times 736 times cosine 3. And I get x squared is 33887 about. Now, when you're doing this for homework, it specifically says in the word problems, but don't round in the process, round in your final answer. But so I rounded in my work with what I wrote down here, but with what I type in the calculator, I am not going to want to round because every little bit of rounding can create some error. And this is not our final answer yet, as we talked about with our law of cosines, commonly forgotten, but we need to take a square root here still. So on my calculator, what I'm going to type in is square root second, and then answer is that little negative button. So I'm going to do the square root of, and then second and that little negative button so that it does the whole last answer without any rounding at all, so that I get as precise of an answer as possible. And this is 184.08, and then there are some more places, but I think it usually wants you to go to 2 decimal places. So we find then that Orion's belt is 184 about light years across. Light years is actually a measure of distance. It sounds like time because years, but it's actually a measure of distance. Okay, so that's our first modeling example there. In our next example, what we're going to have is, again, we'll have a house here. Somebody's at home, and close to their house is a mountain. So here's our mountain. And if they walk from their house to the base of the mountain, it's 750 meters, so not far at all. And if they stand at their house and they look up to the peak of the mountain, they have a 40-degree angle of elevation. And they know that the slope of the mountain is a 50-degree angle of elevation. And what they want to know is how long is the hike up the mountain there. Okay, so this is our problem that we have. There's actually 3 triangles in this picture. So maybe you don't see 3 right away. There's the obtuse one over on the side. There's the mountain, but then the whole thing is actually a triangle also. So you might kind of be like, well, what triangle are we going to use in this? I'm going to use the triangle that has a measurement in it of 750 so that I have at least a side. We always need at least one side to use either law of sines or cosines. So here's that purple triangle is the triangle that I'm going to use. Now I don't know very much in there. I know the 40. There's that 50, but the 50 is not in the triangle. It's next to the triangle. But I do know from geometry that a straight line makes 180 degrees. So I could find out that that angle would have to be 130 because 2 angles next to each other make a straight line. They have to make 180 degrees. I also know from geometry that the 3 angles in a triangle have to add up to 180 degrees. So now inside of that purple triangle, I have 40 and 130, so I have 170. So that means that that little angle at the top of that purple triangle would have to be 10 degrees. And now I know a whole lot about that purple triangle. I know all of the angles and I know one of the sides. And I want to know another side, x. So now I want to decide law of sines or law of cosines. Law of sines can be used when we have pairings of angles and sides across from each other. Because we have all of the angles here, we definitely have pairings. Now opposites a little bit hard because it's so narrow here, but the 10 and the 750, those are opposite of each other. And then x, we need to use x because that's what we're trying to find. X and 40 are opposite of each other. So that's how we're going to set up our law of sines. Sine of 40 over x and sine of 10 over 750. 750, and that will be our law of sines. So now to solve this, because that x is on the bottom, I'm going to do a cross multiply, and I'm going to say 750 sine of 40 is equal to x sine of 10. And I want to get that x alone, so I'm going to divide by sine of 10. And then I'll get that x alone on that side, and then I'm going to type into my calculator this law of sines, remembering when I press sine, it opens parentheses, and I need to close them back up. So 750 sine of 40 and close them back up, divided by sine of 10 and close them back up. And I get that x is 2776.25 meters. Okay, so that's how long the hike would be up the mountain. All right, so a couple of examples of trig modeling. Same kinds of problems using law of sines and law of cosines. On Khan Academy, all the pictures are going to be drawn for you already, so that's good. You don't have to create any of your own pictures from the word problems. The pictures will be there for you to reference, and what you want to look for to decide is it law of sines or law of cosines is, do we have those pairings of angles and sides across from each other? Modeling questions can be tricky, so make sure that you ask me whatever questions you have. If you can send me a screenshot, that would be really helpful so I know what problem you're working with, but I'm happy to help you out. All right, so let me know how I can help you, and I'll see you again soon.